Welcome viewers, here is the second part of our topic, sword. In our previous lesson, I gave the definition of sword. I gave several examples. Among these examples is these Euler numbers, the pi, square root of numbers that are not perfect square. So numbers that are not perfect square, they are also examples of what? Of sword. So but all these Euler and the pi, they belongs to examples of an irrational number. Surd itself is under irrational number. It's subset. It's a set inside a set of irrational numbers. Now, but when we say surd, most cases what we consider as surd or what we work with as surd is square root. We also have other roots that can be example of irrational number. But when we talk about surd, we are referring to what we call the square root. And which type of square root? Is it square root of any number? No. It's square root of number that is not a perfect square. Now, the question is, okay, what's a perfect square? Perfect square is square of a number. The result you get when you square a number other than 1. For example, 2 square is what? 4, you can see. 3 square, 9. 4 square, 5 square, 25. 10 square, 100. 15 square, 225, and so on. So here are the list of perfect square. So this extends to infinity. It has no limit. Now, let's consider the following examples now. Here we want to consider reduction of surd. How do we reduce surd? So we reduce surd especially when you have a big number, a big value, large value inside the square root. And you observe that there is a perfect square that can divide such number. Before you can reduce a surd, a perfect square must be factor of such number. For example, all these numbers, they are big because they are more than 2. But despite that square root of 15 is bigger than 12, we cannot reduce square root of 15, but we can reduce square root of 12. These are perfect square. Among the list of numbers we have, which one can divide 15? Which one can go in 15 completely? There is none. 4 cannot divide without a remainder. 9 cannot. So square root of 12 is a surd that can be reduced in the sense that there is a perfect square that can divide it. So among the perfect square that can divide 12 is 4. How many 4 goes in 12? That is why we express square root of 12 as square root of 4 times 3. 4 times 3 equals to 12. Now, since 4 is a perfect square, we can find square root of 4. What's square root of 4? 2. You keep that 2 outside. We cannot find square root of 3, so this 3 will remain inside. Now, the next example we have here, we have square root of 98. Now, again, we check for perfect square that is a factor of 98. So, among the list of perfect square we have there, it's only 49 is a factor of 98. Now, because of that, how many 49 go? Or 49 multiplied by what will give us 98? That is 49 times 2. So because of that, we express this 98 as 49 times 2. Now, we can find square root of 49 because 49 is a perfect square. Square root of 49 is 7. So that 7 will remain outside. We cannot find square root of 12 of 2. So 2 will still remain inside the root. The next one. Now, the next example, we have 2 square root of 243. The difference between this example and the previous examples is that we have a value outside the root, which is coefficient of this root. Now, we want to reduce this again. We check for the perfect square that can divide 243. If you check carefully here, we have more than one perfect square that can divide 243. 9 can divide 243. 81 can divide 243. So these two values, They are perfect square and they can divide 243. Now, here is what to do. Whenever you have more than one perfect square that can divide the number you have in the root, so you consider the highest. Because if you pick the smaller one, you will still need to reduce again. So what you are going to get will not be in the simple form. So because of that, you consider the highest among the perfect square that are factor of this value. So now we are taking 81. So 81 multiplied by 3 will give us 243. So now we write this as a 2 square root of 81 multiplied by 3. Because 81 times 3 will give us 243. The 2 outside here is this. Now we move again. The 2 you have outside, you write it. Now you use the multiplication sign because you want to bring out another number. Outside this, you want to bring out a value from this root now. So you say multiply by. Now, what's square root of 81? 9. So multiply by 9. Then you cannot find square root of 3, so that 3 will remain inside the root. Now, please take note, you don't multiply the number you have inside the root with the one outside. So because of that, it's only those that are outside you can multiply together, while those numbers in the root can also be multiplied together. So now 2 times 9, that is 18 square root of 3. Another one, we have just similar to this one. The last example here, we have 3 square root of 125. Now, this square root of 125, the only perfect square among the perfect square we have here that can divide 125 is 25. So 25 can divide 125. So you express this again. The 3 outside, you keep it. Now, square root of. Now, 125 is 25 times 5. So 25 times 5 equals to 125. Now we can find the square root of 125. We cannot find this. So now 3 you have outside, you keep it again, just like this example. Then you multiply. Now what's square root of 25? 5. Then 5 inside there, you cannot find the square root, so you keep it in the root. Please don't get it wrong. We have 3 outside, this is it. 25, square root of 25 is 5. That 5 will come out, this is it. But this one you cannot find the square, so that's why you have inside the root. Now multiply these two together. 3 times 5, 15. Square root of 5. So you cannot find it, so you keep it in the root. Now all the following examples are expressed in the simple form. Because we cannot further reduce 3, we cannot further reduce any of this value again. You can't reduce 5, you cannot. So now it means you have done what you are expected to do. So this is how to reduce surd in simple form. Or in some cases, you may just be asked to simplify. If you ask to simplify, you are given something like this. What should come to your mind is you're expected to reduce. Another application of this reduction of surd is that we can easily identify surds that are similar. We can easily identify surds that are what? That are similar. How do we know that 2 surds are similar? 2 surds are similar when they have the same value inside the root. Similar surd. Similar surds. So now we say 2 surds are similar when the value inside the roots are the same. Example of similar surd. You can see the square root of 12 and the square root of 243. When after the reduction, we got this one becomes 2 root 3. After reduction, 243 also become what? It becomes 9 root 3. You can see that the value you have inside the roots are the same. So it means they are similar. Another example of similar surds that are similar to this 7 root 3. Once you have multiple of square root of 3, all the multiples of a square root of 3 are all what? They are all similar. Not only square root of 3, once the value inside the root are the same. Another similar sort, when you have 2 root 5 and maybe 7 root 5, you can see that what you have inside they are also the same. So they are also similar. So that is one of the applications of this reduction of sort. You can easily identify sorts that are similar with help of what? With help of reduction. Once you reduce it into the simple form, you can easily see those that are similar. And that is the end of this class. So in our next class, we shall consider the rules of sort. Watch out for that. Thank you.